A hot air balloon is a lighter-than-air aircraft consisting of a bag called the envelope that is capable of containing heated air. Suspended beneath is a gondola, or a wicker basket, which carries passengers and a source of heat, in most cases an open flame. The heated air inside the envelope makes it buoyant since it has a lower density than the relatively cold air outside the envelope. As with all aircraft, hot air balloons cannot fly beyond the atmosphere. Unlike gas balloons, the envelope does not have to be sealed at the bottom since the air near the bottom of the envelope is at the same pressure as the air surrounding. For modern sport balloons, the envelope is generally made from nylon fabric and the inlet of the balloon is made from fire-resistant materials such as Nomex. Beginning during the mid-1970s, balloon envelopes have been made in all kinds of shapes, such as rocket ships and the shapes of various commercial products, though the traditional shape remains popular for most non-commercial and many commercial applications. The hot air balloon is the first successful human-carrying flight technology. The first untethered manned hot air balloon flight was performed by Jean-François Pilot de Rosier and François-Laurent Darlandes on November 21, 1783, in Paris, France, in a balloon created by the Montgolfier brothers. The first hot air balloon flown in the Americas was launched from the Walnut Street Jail in Philadelphia on January 9, 1793 by the French aeronaut Jean-Pierre Blanchard. Hot air balloons that can be propelled through the air rather than simply drifting with the wind are known as thermal airships. History. Pre-modern and unmanned balloons. Early unmanned hot air balloons were used in China. Zhu Liang of the Shu Han Kingdom, during the Three Kingdoms era, used airborne lanterns for military signaling. These lanterns are known as Kongming lanterns. The first documented balloon flight in Europe was demonstrated by Bartholomew de Gauchemau. On August 8, 1709, in Lisbon, he managed to lift a balloon full of hot air about 4.5 meters in front of King John V and the Portuguese court. First manned flight. The brothers Joseph Ralph and Jacques-Étienne Montgolfier developed a hot air balloon in Annonay, Ardèche, France, and demonstrated it publicly on September 19, 1783, making an unmanned flight lasting 10 minutes. After experimenting with unmanned balloons and flights with animals, the first balloon flight with humans aboard, a tethered flight, performed on or around October 15, 1783, by Étienne de Montgolfier, who made at least one tethered flight from the yard of the Revon workshop in the Faubourg Saint-Antoine. Later that same day, Pilot de Rosier became the second human to ascend into the air, reaching an altitude of 24 meters, the length of the tether. The first free flight with human passengers was made a few weeks later, on November 21, 1783. King Louis XVI had originally decreed that condemned criminals would be the first pilots, but de Rosier, along with Marquis François Darlandes, petitioned successfully for the honor. The first military use of a hot air balloon happened in 1794 during the Battle of Fleurus, when the French used the balloon l'Entreprenant for observation. Today modern hot air balloons, with an onboard heat source, were developed by Jost. Beginning during the 1950s, his work resulted in his first successful flight on October 22, 1960. The first modern hot air balloon to be made in the United Kingdom was the Bristol Belle, built in 1967. Presently, hot air balloons are used primarily for recreation. Hot air balloons are able to fly to extremely high altitudes. On November 26, 2005, Vijay Patsingania set the world altitude record for highest hot air balloon flight, reaching 21,027 meters. He took off from downtown Mumbai, India, and landed 240 kilometers south in Panchayal. The previous record of 19,811 meters had been set by Palindstron on June 6, 1988, in Plano, Texas. On January 15, 1991, the Virgin Pacific Flyer balloon completed the longest flight in a hot air balloon when Palindstron and Richard Branson of the UK flew 7,671.91 kilometers from Japan to northern Canada. With a volume of 74,000 cubic meters, the balloon envelope was the largest ever built for a hot aircraft. Designed to fly in the transoceanic jet streams, the Pacific Flyer recorded the fastest ground speed for a manned balloon at 245 miles per hour. The longest duration record was set by Swiss psychiatrist Bertrand Piccard, Auguste Piccard's grandson, and Briton Brian Jones, flying in the Breitling Orbiter 3. It was the first non-stop trip around the world by balloon. The balloon left Chateau d'Oex, Switzerland, on March 1, 1999, and landed at 1:02 a.m. on March 21 in the Egyptian desert 300 miles south of Cairo. The two men exceeded distance, endurance, and time records, traveling 19 days, 21 hours, and 55 minutes. Steve Fossett exceeded the record for briefest time traveling around the world on the 3rd of July 2002. The new record is 328.33 minutes. Construction. A hot air balloon for manned flight uses a single-layered fabric gas bag with an opening at the bottom called the mouth or throat. Attached to the envelope is a basket, or gondola, for carrying the passengers. Mounted above the basket and centered in the mouth is the burner, which injects a flame into the envelope, heating the air within. The heater, a burner, is fueled by propane, a liquefied gas stored in pressure vessels, similar to high-pressure forklift cylinders. Envelope. Modern hot air balloons are usually made of materials such as ripstop nylon or Dacron. During the manufacturing process, the material is cut into panels and sewn together, along with structural load tapes that carry the weight of the gondola or basket. The individual sections, which extend from the throat to the crown of the envelope, are known as gauze or gore sections. Envelopes can have as few as 4 gauze or as many as 24 or more. Envelopes often have a crown ring at the very top. This is a hoop of smooth metal, usually aluminium, and approximately 1 foot in diameter. Vertical load tapes from the envelope are attached to the crown ring. At the bottom of the envelope, the vertical load tapes are sewn into loops that are connected to cables. These cables, often referred to as flying wires, are connected to the basket by carabiners. Seems the most common technique for sewing panels together is called the French fell, or double lap seam. The two pieces of fabric are folded over on each other at their common edge, possibly with a load tape as well, and sewn together with 2 rows of parallel stitching. Other methods include a flat lap seam, in which the 2 pieces of fabric are held together simply with 2 rows of parallel stitching, and a zigzag, where parallel zigzag stitching holds a double lap of fabric. Coatings. The fabric may be coated with a sealant such as silicone or polyurethane to make it impermeable to air. It is often the degradation of this coating and the corresponding loss of impermeability that ends the effective life of an envelope, not weakening of the fabric itself. Heat, moisture, and mechanical wear and tear during setup and pack-up are the primary causes of degradation. Once an envelope becomes too porous to fly, it may be retired and discarded or perhaps used as a rag bag, cold inflated and open for children to run through. Products for recoating the fabric are becoming available commercially. Sizes and capacity. A range of envelope sizes is available. The smallest one-person basket-less balloons have as little as 600 cubic meters of envelope volume. For a perfect sphere, the radius would be around 5 meters. At the other end of the scale, balloons used by commercial sightseeing operations may be able to carry well over 24 people, with envelope volumes of up to 17,000 cubic meters. The most used size is about 2,800 cubic meters and can carry 3 to 5 people. Vents. The top of the balloon usually has a vent of some sort, enabling the pilot to release hot air to slow an ascent, start a descent, or increase the rate of descent, usually for landing. Some hot air balloons have turning vents, which are side vents that, when opened, cause the balloon to rotate. Such vents are particularly useful for balloons with rectangular baskets, to facilitate aligning the wider side of the basket for landing. The most common type of top vent is a disc-shaped flap of fabric called a parachute vent, invented by Tracy Barnes. The fabric is connected around its edge to a set of vent lines that converge in the center. These vent lines are themselves connected to a control line that runs to the basket. A parachute vent is opened by pulling on the control line. Once the control line is released, the pressure of the remaining hot air pushes the vent fabric back into place. A parachute vent can be opened briefly while in flight to initiate a rapid descent. The vent is pulled open completely to collapse the balloon after landing. An older, and presently less commonly used, style of top vent is called a Velcro-style vent. This too is a disc of fabric at the top of the balloon. However, rather than having a set of vent lines that can repeatedly open and close the vent is secured by hook and loop fasteners and is only opened at the end of the flight. Balloons equipped with a Velcro-style vent typically have a second maneuvering vent built into the side of the balloon. Another common type of top design is the smart vent, which, rather than lowering a fabric disc into the envelope as in the parachute type, gathers the fabric together in the center of the opening. This system can theoretically be used for in-flight maneuvering, but is more commonly used only as a rapid deflation device for use after landing, of particular value in high winds. Other designs, such as the pop-top and multi-vent systems, have also attempted to address the need for rapid deflation on landing, but the parachute top remains popular as an all-around maneuvering and deflation system. Shape. Besides special shapes, possibly for marketing purposes, there are several variations on the traditional inverted teardrop shape. The simplest, often used by home builders, is a hemisphere on top of a truncated cone. More sophisticated designs attempt to minimize the circumferential stress on the fabric, with different degrees of success depending on whether they take fabric weight and varying air density into account. This shape may be referred to as natural. Finally, some specialized balloons are designed to minimize aerodynamic drag to improve flight performance in competitions. Baskets are commonly made of woven wicker or rattan. These materials have proven to be sufficiently light, strong, and durable for balloon flight. Such baskets are usually rectangular or triangular in shape. They vary in size from just big enough for 2 people to large enough to carry 30. Larger baskets often have internal partitions for structural bracing and to compartmentalize the passengers. Small holes may be woven into the side of the basket to act as footholds for passengers climbing in or out. Baskets may also be made of aluminium, especially a collapsible aluminium frame with a fabric skin, to reduce weight or increase portability. These may be used by pilots without a ground crew who are attempting to set altitude, duration, or distance records. Other specialty baskets include the fully enclosed gondolas used for around-the-world attempts, and baskets that consist of little more than a seat for the pilot and perhaps one passenger. The burner unit gasifies liquid propane, mixes it with air, ignites the mixture, and directs the flame and exhaust into the mouth of the envelope. Burners vary in power output. Each will generally produce 2 to 3 megawatts of heat, with double, triple, or quadruple burner configurations installed where more power is needed. The pilot actuates a burner by opening a propane valve, known as a blast valve. The valve may be spring-loaded so that it closes automatically, or it may stay open until closed by the pilot. The burner has a pilot light to ignite the propane and air mixture. The pilot light may be lit by the pilot with an external device, such as a flint striker or a lighter, or with a built-in piezoelectric spark. Where more than one burner is present, the pilot can use one or more at a time depending on the desired heat output. Each burner is characterized by a metal coil of propane tubing the flame shoots through to preheat the incoming liquid propane. The burner unit may be suspended from the mouth of the envelope, or supported rigidly over the basket. The burner unit may be mounted on a gimbal to enable the pilot to aim the flame and avoid overheating the envelope fabric. A burner may have a secondary propane valve that releases propane more slowly and thereby generates a different sound. This is called a whisper burner and is used for flight over livestock to lessen the chance of spooking them. It also generates a more yellow flame and is used for night glows because it lights up the inside of the envelope better than the primary valve. Fuel tanks. Propane fuel tanks are usually cylindrical pressure vessels made from aluminium, stainless steel, or titanium with a valve at one end to feed the burner and to refuel. They may have a fuel gauge and a pressure gauge. Common tank sizes are 10, 15, and 20 US gallons. They may be intended for upright or horizontal use, and may be mounted inside or outside the basket. The pressure necessary to force the fuel through the line to the burner may be supplied by the vapor pressure of the propane itself, if warm enough, or by the introduction of an inert gas such as nitrogen. Tanks may be preheated with electrical heat tapes to produce sufficient vapor pressure for cold weather flying. Warm tanks will usually also be wrapped in an insulating blanket to preserve heat during the setup and flight. Instrumentation. A balloon may be outfitted with a variety of instruments to aid the pilot. These commonly include an altimeter, a rate of climb indicator known as a variometer, envelope temperature, and ambient temperature. A GPS receiver can be useful to indicate ground speed and direction. Combined mass. The combined mass of an average system can be calculated as follows, using a density of 0.9486 kilograms per cubic meter for dry air heated to 210 degrees Fahrenheit. Theory of operation. Generating lift. Increasing the air temperature inside the envelope makes it less dense than the surrounding air. The balloon floats because of the buoyant force exerted on it. This force is the same force that acts on objects when they are in water and is described by Archimedes' principle. The amount of lift provided by a hot air balloon depends primarily upon the difference between the temperature of the air inside the envelope and the temperature of the air outside the envelope. For most envelopes made of nylon fabric, the maximum internal temperature is limited to approximately 120 degrees Celsius. It should be noted that the melting point of nylon is significantly greater than this maximum operating temperature, about 230 degrees Celsius, but higher temperatures cause the strength of the nylon fabric to degrade more quickly over time. With a maximum operating temperature of 120 degrees Celsius. Balloon envelopes can generally be flown for between 400 and 500 hours before the fabric needs to be replaced. Many balloon pilots operate their envelopes at temperatures significantly less than the maximum to extend envelope fabric life. The lift generated by 100,000 feet cubed of dry air heated to various temperatures may be calculated as follows. The density of air at 20 degrees Celsius (68 degrees Fahrenheit) is about 1.2 kilograms per cubic meter. The total lift for a balloon of 100,000 feet cubed heated to would be 1,595 pounds, 723.5 kilograms. This is just enough to generate neutral buoyancy for the total system as stated in the previous section. Liftoff would require a slightly greater temperature, depending on the desired rate of climb. In reality, the air contained in the envelope is not all the same temperature as the accompanying thermal image shows, and so these calculations are based on averages. For typical atmospheric conditions, a hot air balloon heated to requires about 3.91 cubic meters of envelope volume to lift 1 kilogram. The precise amount of lift provided depends not only upon the internal temperature mentioned above, but the external temperature, altitude above sea level, and humidity of the air surrounding. On a warm day, a balloon cannot lift as much as on a cool day, because the temperature required for launch will exceed the maximum sustainable for nylon envelope fabric. Also, in the lower atmosphere, the lift provided by a hot air balloon decreases about 3% for each 1,000 meters of altitude gained. Montgolfier standard hot air balloons are known as Montgolfier balloons and rely solely on the buoyancy of hot air provided by the burner and contained by the envelope. This style of balloon was developed by the Montgolfier brothers, and had its first public demonstration on the 4th of June 1783 with an unmanned flight lasting 10 minutes, followed later that year with manned flights. Hybrid. The 1785 Rosier balloon, a type of hybrid balloon, named after its creator, Jean-François Pilot de Rosier, has a separate cell for a lighter-than-air gas as well as a cone below for hot air to heat the helium at night. Hydrogen gas was used in the very early stages of development but was quickly abandoned due to the obvious danger of introducing an open flame near the gas. All modern Rosier balloons now use helium as a lifting gas. Solar balloons are hot air balloons that use just solar energy captured by a dark envelope to heat the air inside. Safety equipment. To help ensure the safety of pilot and passengers, a hot air balloon may carry several pieces of safety equipment in the basket, to relight the burner if the pilot light goes out and the optional piezo ignition fails. The pilot should have ready access to a means of backup ignition, such as a flint spark lighter. Many systems, especially those that carry passengers, have completely duplicate fuel and burner systems. Two fuel tanks, connected to two separate hoses, which feed two distinct burners. This enables a safe landing in the case of a blockage somewhere in one system or if a system must be disabled because of a fuel leak. A fire extinguisher suitable for extinguishing propane fires is useful. Most balloons carry a 1 or 2 kilograms AB-type fire extinguisher. Handling a drop line is mandatory safety equipment in many countries. This is a rope or webbing of 20 to 30 meters in length attached to the balloon basket with a quick-release connection at one end. In very calm winds, the balloon pilot can throw the handling line from the balloon so that the ground crew can guide the balloon safely away from obstructions on the ground. For commercial passenger balloons, a pilot restraint harness is mandatory in some countries. This consists of a hip belt and a webbing line that together allow for some movement while preventing the pilot from being ejected from the basket during a hard landing. Further safety equipment may include a first aid kit, a fire blanket, and a strong rescue knife. On the occupants, at a minimum, the pilot should wear leather or flame-retardant fiber gloves, so that he may shut off a gas valve in the case of a leak. Even if there is a flame present, quick action in this regard can turn a potential catastrophe into a mere inconvenience. He should additionally wear flame-resistant clothing covering his arms and legs, either natural fiber, such as cotton, linen, hemp, or wool, or engineered flame-retardant fiber, such as Nomex, is acceptable in this capacity. Most engineered fibers are thermoplastic, many are also hydrocarbons. This makes such fabrics very much unsuitable to wear near high temperatures, since non-flame retardant thermoplastics will melt onto the wearer, and most hydrocarbons, whether fibrous or not, are suitable to use as fuels. Natural fiber will singe rather than melt or burn readily, and flame-retardant fiber generally has a very high melting point and is intrinsically non-flammable. Many pilots also advise the passengers to wear similar protective clothing that covers their arms and legs, as well as strong shoes or boots that offer good ankle support. Finally, some balloon systems, especially those that hang the burner from the envelope instead of supporting it rigidly from the basket, require the use of helmets by the pilot and passengers. On the ground crew, the ground crew should wear gloves whenever there is a possibility of handling ropes or lines. The mass and exposed surface to air movement of a medium-sized balloon is sufficient to cause rope friction burns to the hands of anyone trying to stop or prevent movement. The ground crew should also wear sturdy shoes and at least long pants in case of the need to access a landed balloon in rough or overgrown terrain. Maintenance and repair. As with aircraft, hot air balloons require regular maintenance to remain airworthy. As aircraft made of fabric and that lack direct horizontal control, hot air balloons may occasionally require repairs to rips or snags, while some operations, such as cleaning and drying, may be performed by the owner or pilot. Other operations, such as sewing, must be performed by a qualified repair technician and recorded in the balloon's maintenance logbook. Maintenance to ensure long life and safe operation. The envelope should be kept clean and dry. This prevents mold and mildew from forming on the fabric and abrasion from occurring during packing, transport, and unpacking due to contact with foreign particles. In the event of a landing in a wet or muddy location, the envelope should be cleaned and laid out or hung to dry. The burner and fuel system must also be kept clean to ensure safe operation on demand. Damaged fuel hoses need to be replaced. Stuck or leaky valves must be repaired or replaced. The wicker basket may require occasional refinishing or repair. The skids on its bottom may require occasional replacement. Balloons in most parts of the world are maintained in accordance with a fixed manufacturer's maintenance schedule that includes regular inspections, in addition to maintenance work to correct any damage. In Australia, balloons used for carrying commercial passengers must be inspected and maintained by approved workshops. Repair in the case of a snag, burn, or rip in the envelope fabric. A patch may be applied or the affected panel completely replaced. Patches may be held in place with glue, tape, stitching, or a combination of these techniques. Replacing an entire panel requires the stitching around the old panel to be removed, and a new panel to be sewn in with the appropriate technique, thread, and stitch pattern.